All right, hello everyone. So today we'll be talking about the GIKE2. My name is Praveena Shanubhogue. I'm with Cisco TAC. I work on VPN technologies mostly. I've been here for the last 6 years. Mostly I work on IPsec VPN, SSL VPN, and PKI. I have with me my colleague Salah Gherdaoui. He's also a Cisco TAC engineer. We work at the same office here in Krakow. He's been here for the last 2.5 years. His expertise is IPsec VPN at the protocol level, IKEv1 and IKEv2. So what we will be talking today is GIKE2. G stands for GetVPN or Group Key Management. Before I cover this agenda, I just wanted to understand, who here has worked on GetVPN in the past? You have, okay. No worries, we'll be covering the basics of what GetVPN is. What is GetVPN, where would you deploy GetVPN, and the components of GetVPN. Once we cover the components of GetVPN, we'll talk about group key management with IKEv1, the previous protocol known as Gherdaoui, and the new one, which is the topic of our discussion today, group key management with IKEv2, known as GIKE2. What is GIKE2? How does GIKE2 work? We'll cover there, and then we'll talk about Gherdaoui to GIKE2 migration. And then we'll give you a brief history of how GetVPN started and where it is at and what's the future for GetVPN. So throughout the presentation, we'll be mentioning a lot of keywords, GetVPN, group key management. These keywords are interchangeable. So you have to understand that this is a group-based VPN. So GetVPN. What is GetVPN? GetVPN is a solution that provides any-to-any secure communication without forming any tunnels. What I mean by that is you have a private network, such as MPLS. Since you have a private network and you have any-to-any communication already, basically the MPLS provides end-to-end routing. You don't want to set up another virtual private network. What group encrypted transport provides is you have boundary devices. We call them group members in just a while. We'll take a look at that. Those are programmed to encrypt and decrypt without forming any tunnels with the other branch. So GetVPN makes use of native routing. Because we make use of native routing, how we do that we'll see in just a while. We can make use of the underlying QoS that's deployed in the network. Also, we make use of the multicast replication that's provided by the private network. Also, we'll be talking about MPLS a lot, but GetVPN can be deployed anywhere as long as you have any-to-any routing in place. Quickly, on that side, you will see point-to-point tunnels, and on this side, you will see GetVPN, which is tunnel-less VPN. Say you have n branches in your network. If you want to set up full mesh topology, branch-to-branch communication, you will end up with n squared number of tunnels. But in case of GetVPN, because there are no tunnels, because the devices are programmed to encrypt from any source to any destination, we'll see how we do that, it's highly scalable. It's as scalable as your original network. And that also provides you with instant any-to-any communication or connectivity. Whereas in case of point-to-point VPN tunnels, you have to set up the tunnel, you have to negotiate the tunnel, and then you start communicating. Also, we've spoken about the underlying QoS that's implemented by the provider. You can make use of it because you use their own routing infrastructure. So where would you position GetVPN as a solution? So usually in last deployments, you would have branches with primary network as MPLS and backup as internet. As you know, over the internet, if the branches want to send confidential information, you use technologies such as DMVPN or FlexVPN, where you have hub and spoke model, or EasyVPN or site-to-site VPN. Also, you have remote access VPN software such as AnyConnect or IPsec clients and things like that. But in case of MPLS, because it's already a private network, it gives you end-to-end routing. Unlike internet, private network cannot be routed over internet, but here everything is routable. You can use GetVPN. These are not tunnel notation, it's just showing you that end-to-end encryption is provided by Get. A quick comparison of FlexVPN, DMVPN, and Get. What we want to point out here again is you have a private IP transport where we make use of any-to-any secure communication using the native routing that's available. We'll quickly cover the components, and then if we have any questions so far, we'll take that. So we have two components in GetVPN. First one is key servers. Key servers are the brains of the operation. They calculate the keys, and they program the group members. And then we have the group members, which get the keys from the key server. They are the encrypting and decrypting devices. Next up, we have three main concepts that the GetVPN uses. First one is secure group keys. These are the keys that are calculated by the key server. These protect the control channel communication between the group member and the key server. Also, between the group members, the group members are programmed to encrypt and decrypt, which are synchronized. And then we have something called header preservation. We'll talk about that in just a minute. But what header preservation provides you with is the private IP network, the routing that's provided by the private IP network. We can make use of that using header preservation. We'll talk in detail about header preservation in just a second. Finally, we have key services. Key services is nothing but the mechanisms defined on how to calculate the keys at the key server, also how to distribute the keys from the key server to the group member. So with these in place, you have an idea of what GetVPN is. So at the top, you have a key server. On the key server, you define the policy. The policy could be as simple as any-to-any. Or you could define, I don't want to encrypt EIGRP, I don't want to encrypt BGP, basically the routing protocols, but I want to encrypt everything else. You could also deny SSH because it's already encrypted. These kind of policies go on the key server. You define the encryption algorithm, the hashing algorithm, and then these are the key servers that validate, authenticate. So basically, you need a mechanism to authenticate the group member who can join and start encrypting. That is done by the key server. And this is the one which calculates the keys and sends across to group members. We have two types of keys. One is called KEK. KEK is key encryption key, which means that this is the key that encrypts the traffic encryption key. KEK protects the control plane because control plane here refers to the communication between the group members and the key server. And then you have TEK. TEK is the traffic encryption key. Anytime the TEK, which is the traffic encryption key, has to be sent from the key server to the group member, it's encrypted with KEK. So hence, key encryption key and traffic encryption key. And traffic encryption key is the key that's used by the group members to encrypt the traffic from any source to any destination. Finally, the group members, these get the keys from the key server and start encrypting the minute they get the keys. So as you can see, the group members draw a boundary between secured network and non-secured network. Any questions so far? Okay. So earlier I mentioned the header preservation that we do. We'll quickly talk about how we do it in IPsec tunnel mode. So you have an IP packet from your private network that needs to go across an IPsec tunnel over the internet to another private network. And because the private network cannot be routed over the internet, you encrypt it, encapsulate it within ESP, and then you add a new IP header. And this new IP header is the source and destination of your VPN gateway. And because these are routable, it goes over the internet. But in case of GetVPN, as I already mentioned, you have the underlying routing network from end to end. So you have the original IP packet, you encrypt it, encapsulate it within ESP. But before you do that, you take the original IP header and you preserve it. So you basically copy and paste it. With this, any marking that you have in the original IP header, that's preserved. So you can use the QoS marking. And we can make use of the underlying routing infrastructure provided by your private network. Okay, so with these components in place, so you have key servers, you have group members, we have header preservation concept, and we have the keys that's distributed from the key server and the group member. We'll quickly talk about how we made use of GIKE-v1 to sort of put all these together and form GetVPN. So we make use of something called Gherdaoui. It's defined in RFC 6407. It's one of the RFCs co-authored by a couple of Cisco people. It makes use of ISACAMP framework. ISACAMP, as defined in GIKE-v1, RFC 2407, 2408, and 2409. So we reuse phase 1 of ISACAMP to authenticate the group member as it is without it changing anything, except we go over UDP port 848. So once we've authenticated the group member, we've defined 2 new phase 2 protocol exchanges to give the keys to the group members and keep doing it while performing rekey. So first one is, once the group member authenticates to the key server, we perform something called registration. It's initiated by the group member. It says which group it wants to join and gets the key from the key server. Hence, it's known as a pull, because group member pulls the key from the key server. The next one is group key push. So as you know, in case of point-to-point IPsec VPN tunnel, you have branch-to-branch communication. You define the lifetime of the IPsec security association. Once it expires, you have to rekey it. But in case of GetVPN, because the key server is the brain of the operation, he calculates the key, he rekeys it, and he pushes that to all those registered GMs when the lifetime is about to expire. Hence, it's known as push. So basically, it's a pull and push model. Quickly, we have group member on that side, key server here. The phase 1 exchange, the group member says which policy, the encryption algorithm, hashing algorithm to protect the phase 1 negotiation. The key server accepts it. And then we have Diffie-Hellman key exchange where the shared key is exchanged. And finally, because we have shared secret already computed, we protect the next messages where they authenticate each other. So with this, we have the group member and the key server authenticated. Following this, the group member says which group it wants to join. We will see in just a while what is a group, how you identify a group, but group member says which group it wants to join. Key server says, okay, if you want to join this group, we've defined this policy in this group. You have to encrypt this using this encryption algorithm. Group member acknowledges, and finally we send KEK and TEK. From henceforth, we make use of KEK and TEK as long as the group member stays registered. And the minute it gets KEK and TEK, it's ready to go. It'll start encrypting and decrypting. And then we have rekey. Here, we have 2 types of rekey. In the RFC, we define a multicast rekey where the group member is programmed to listen to a single multicast address. And the key server sends the packet on that multicast address, and the private network that you have, it replicates the packet and gives it to all the group members. There is no acknowledgement. We just send it out, hoping that the group member will get. And for this, you have the private network that has to be multicast enabled. Following this, what if the private network is not multicast enabled? So we came up with unicast rekey, where the rekey is sent targeted to each of the group members, and we expect an acknowledgement from each of the group member to know that the rekey has reached him. Once the essays expire, the rekey essays are installed, and it's good to go. So this is a continuous process, and this is protected by GIKE. Rekey methodology, we've spoken about it. Key server sends a multicast rekey, goes to all the group members, and they're good to go. In case of unicast rekey, the key server maintains a state for each of the group members and expects an acknowledgement. If the acknowledgement is not received, it retransmits it for a configurable amount of time. And if it doesn't get 3 consecutive acts, then we delete the group member. So a quick question. So you have a single key server in the network, and you have thousands of group members that are depending on this key server. So key server is the one which calculates the keys and sends it across. So what if you have single key server and thousands of group members that are depending on it? What is the problem, or what's the worst thing that can happen in this network? Yes. So we need a solution that's redundant, in the sense, if the key server dies, then we need another key server to take the role of the key server. So that's where Cisco came up with another proprietary protocol called cooperative key service, also known as COOP. You will see it a lot. So when you have more than one KS, one of the KSs is elected as primary. There's going to be an election process. One of the KS becomes primary. But the group members can register to any of the available key servers, with one catch, that the primary KS is the one which calculates the key and distributes the key all the time. It keeps it synchronized with the rest of the key servers, and the primary KS has to have reachability to all the group members, as simple as that. So this wraps up the GIKE-v1, the way we did it. And the main discussion topic today is GIKE-v2. How we improved it is something that my colleague Salah will cover.
Okay. So group key management with GIKE-v2. So why do we need a new group key management protocol? If you recall, GIKE-v1 for Gherdaoui, we're using GIKE-v1, and GIKE-v1 was written like 20 years ago, more or less, and it's quite outdated now. Since then, we replaced the protocol with GIKE-v2, and GIKE-v2 comes with the following advantages. So, to name a few, we have reduced network latency for Gherdaoui. To finish the registration, you need 10 messages, while with GIKE-v2, you only need 4. So if you have 1,000 GMs, you need 10,000 messages in the network, while with GIKE-v2 you only need 4,000. You also have GIKE fragmentation support at the GIKE layer and not at the IP layer. So as stack engineer, we saw a lot of issue when the ISP is dropping fragment packets. So now you can fragment at the GIKE layer and not at the IP layer anymore. So these kind of issues will be gone. Also, we added the support for Suite B algorithms, things like elliptic curve, GCM, counter modes, ciphers. And we also inherited from the iOS GIKE-v2 implementation. So now if you want to put your pre-shared key on a Regis server, let's say you have also 1,000 GM, instead of putting 1,000 password on the router, you can put them on a Regis server. So how does it work, and how do we manage to come from 10 messages up to only 4? So the idea basically is that we compressed a little bit the exchange. So we start with the IKSA init. So we negotiate the policy and we perform the Diffie-Hellman exchange. If you recall, before it was done in 4 messages, now we do it only with 2. Then we use the GSA auth exchange, where the group member will authenticate itself to the key server, send the ID of the group he wants to join. Then the key server will reply with the keys and the policies and authenticate itself. So this previously was done in 6 messages. Any questions so far? The rekey basically is the same. We have 2 types of rekey. Periodically, we will refresh the keying material with a rekey, 1 multicast, and in case of unicast, we will have the acknowledgement from the group members. So basically, it remains the same. In case of if you already have an IKEv2 SA established, you do not need to re-authenticate. So we defined a new type of exchange, the GSA registration. So for example, if a group members wants to join multiple groups, the first time it will authenticate itself, then to join the other groups, it doesn't need to authenticate itself. So we have more or less the same exchange, but we remove the authentication payload for the authentication. Okay. So let's say now that you want to migrate, how can you do it seamlessly? So the first thing you want to do is go on your primary key server. You will configure a large rekey lifetime for the IPsec, so for the tech, and the control plane for the CAC. Then you will force a rekey. Once all the devices in the network acknowledge the rekey, you will go ahead and upgrade your key server. You start first with the secondary devices, then you go with the primary. Then you enable GIKEv2 on all the servers, and at this point of time, the key servers will be able to accept registration from GIKEv2 group members and Gherdaoui group members. Then, over time, you will upgrade your group members to use GIKEv2, and at that point of time, the Gherdaoui and GIKEv2 group members will be able to communicate using the same tech. So the tech for the IPsec traffic will remain the same. You will have a different CAC for the GIKEv2 device and the Gherdaoui devices. So for unicast rekey, if the key server needs to send a set of rekey to GIKEv2 device, you will use a GIKEv2 rekey, and to unicast device, to Gherdaoui device, it will send a Gherdaoui rekey. In case of multicast, you will send 1 Gherdaoui multicast packet and 1 GIKEv2 packet. So after some time, when you will not be using Gherdaoui anymore, you can go ahead and disable it from the key server. All right, any questions so far? Okay, cool. So just one thing about the CLI. So until now in the configuration, we were using the Gherdaoui keyword to configure GetVPN. If you think about it, now that we have GIKEv2 and Gherdaoui, and since Gherdaoui is only the control plane protocol name, it doesn't make sense to use the Gherdaoui keyword anymore. So we decided to introduce a new keyword, GKM, and it's more suitable for group key management and for GetVPN. And the idea is that for a period of time, we will enable, you will have the possibility to use both Gherdaoui and GKM in the CLI. After some time, we will deprecate the Gherdaoui keyword by hiding it. You will still be able to enter it, but it will be hidden when we do the question mark. And after some more time, when you will upgrade your devices with Gherdaoui, the configuration will be automatically changed to GKM. So let's have a look at quickly at the configuration. So here's a Gherdaoui config for key server using the COOP protocol. So here you have the ISACAMP policy with the preset key. Here, this is where you define the IPsec policy, the way you want to encrypt traffic using that cipher, for example, AES and SHA. The lifetime of the tech, so 70 to 100 seconds. Here you define which traffic you want to encrypt and which traffic you do not want to encrypt. So typically you will deny routing protocols and control plane protocols management and things like that, and you will allow the rest. Here you have the GDI config where you specify the identity number and you define that this is a server, you define the rekey properties, the lifetime, unicast or multicast. Then here you tie the IPsec policy to the server and the IP address. And here you have the redundancy with the priority defining which one will be the primary key server. Here is a configuration of two Gherdaoui GM. So again, you have the ISACAM policy for the phase one. And then you just create a Gherdaoui group and you specify the identity of the group you want to join. If you have some specific traffic you do not want to encrypt, you can use a local deny ACL. So if you really have few IPs that you do not want to encrypt, you can use that. Then you just need to create a crypto map and apply the group under it, and you will apply the crypto map under the interface. So let's have a look at GIKEv2. So what you will need to add, you need to add an IKEv2 profile. You will still have for some time, you will still need to use for some time the ISACAM policy. For two reasons: you might still have some Gherdaoui GMs in the network, and the other reason is that the COOP protocol, so for redundancy, has not migrated to IKEv2 yet. Again, the IPsec policy, it will remain the same. The rest is basically the same, encryption, ACL. One thing that's changed here, so here, for example, you can see that you can use the GKM or Gherdaoui keywords. You will have this new command, GIKEv2, and you will tie it to the IKEv2 profile. And the Gherdaoui keyword, so this is what will define if the key server is Gherdaoui or GIKEv2. One thing is that the Gherdaoui will be by default, so it will be hidden when you do a show run. The rest is basically the same, rekey properties, you tie the IPsec profile, and the COOP configuration will remain exactly the same. Here, an example of GIKEv2 GM. So here, you will have your IKEv2 profile. On the other side, you will have an ISACAM profile. Under the group, under the GKM or Gherdaoui configuration, you specify which protocol for the client you want to use, and you tie it to the IKEv2 profile. Again, the client protocol Gherdaoui is a hidden command. Again, the rest basically is the same. You have your local deny ACL, you apply the Gherdaoui configuration under the crypto map, and you tie your crypto map to your interface. So to conclude this session, let's have a quick look about the history of GetVPN and where we are heading. So GetVPN was first released in 2006, and since then we added few features, things like VRF-aware, GetVPN, SuiteB, and IPv6 for the data plane, TrustSec. One big thing is that one big limitation of GetVPN was due to the COOP protocol. So when the two key server exchange the database, they need to send this using one UDP packet, and the maximum size we have is 64K. So the group member payload was too big and was only allowing us to go up to 4,000 GM. So what we did, we optimized the group member payload, so now it takes less space, and we can now go up to 8,000 GMs. This year, we did some work with IETF and Juniper to improve our interoperability. We added support for ISR9K and GIKEv2. And in the future, what we will do is we will migrate the COOP protocol to IKEv2. And this, since IKEv2 supports fragmentation natively, we will be able to scale more. So we don't have a number yet. It's still under development, but we are aiming to go up to 20,000 GMs. The other thing we will do is a schedule rekey. So typically, you have network issue when you issue a change on the network. So with schedule rekey, what you can do is, if you want, when you will specify when you want to have the rekey. So if you want to have the rekey in the middle of the night and not in the middle of the day when you have important operation ongoing. Any questions? All right, so thank you very much.